Working together, Rachel and Jessie can complete a jigsaw puzzle in 1.5 hours. Rachel takes 4 hours longer than Jessie does when working alone. How long would it take Jessie to complete the puzzle? Our first step in solving a problem is to familiarize ourselves with the problem. We read it carefully, and we are looking for how long it would take Jessie to complete the puzzle. So we will define a variable and very clearly write out what this means. This is important, so at the end we know what we found. Let S equal the number of hours it would take Jessie to complete the puzzle working alone. And then we're also going to need to find Rachel's time, but let's not use another variable. Since Rachel takes 4 more hours than Jessie, S plus 4 equals Rachel's time. And I think we're ready to translate to an equation. And to translate, we're going to use the work principle. And that is that T over A plus T over B equals 1, where T is the time it takes working together, and A in this case would be Jessie's time, and B would be Rachel's time. The time it took working together was 1.5 hours, divided by Jessie's time was S, plus the time it took working together was 1.5 hours divided by Rachel's time, which was S plus 4, and that equals 1. And that gives us our equation to solve with our third step. When we have a rational equation, the very first step we want to do is to clear fractions by multiplying by the least common multiple of the denominators. The LCM of the denominators is S times S plus 4. So we multiply both sides of the equation by S times S plus 4 times 1.5 over S plus 1.5 over S plus 4. And that equals S times S plus 4 times 1. Now we can distribute. Let's talk our way through this. We have S times S plus 4 times 1.5 divided by S. So the S over S would be 1 and would cancel. So this times the first term would just give us 1.5 times S plus 4 plus. Now we have S times S plus 4 times the second term, which is 1.5 divided by S plus 4. Here the S plus 4 in the denominator and the S plus 4 in the numerator will cancel, and we'll be left with 1.5 times S. If that is not clear, another step in between here is fine to write out so you can see that. Then we have S times S plus 4 times 1, which would give us S squared plus 4S. And now that we've cleared the fractions, we see we have a quadratic equation because we have an S squared term. So let's simplify and collect all the terms on one side and a 0 on the other side. Multiplying, we have 1.5S plus 6 plus 1.5S equals S squared plus 4S. Adding, we get 3S plus 6 equals S squared plus 4S. And then we subtract 3S from both sides, and we'll also subtract 6 from both sides. And we get 0 equals S squared plus S minus 6. Since we have a 0 on one side and a quadratic expression on the other, we will factor and use the principle of zero products. Our equation is 0 equals S squared plus S minus 6. Factoring, 0 equals S plus 3 times S minus 2. Setting each factor equal to 0, S plus 3 equals 0, or S minus 2 equals 0. So we have S equals negative 3, or S equals 2. And we're ready to go to our fourth step, which is to check. And the two values we're looking at checking are negative 3 and 2. Now, first of all, we're thinking about time. Since time can't be negative, this is not going to be a possible solution. So we just need to check 2. If S is 2, then we would have Jesse's time, 2 hours, and Rachel's time, 6 hours, which is S plus 4. And in 1.5 hours, we would have 1.5 divided by 2 would be the amount of work Jesse does, plus 1.5 divided by 6 would be the amount of work that Rachel does, and that adds up to 1. So that does check. And so as a final step, we would state it would take Jesse 2 hours to complete the puzzle working alone.